Alrighty, let's get rid of that Z table and see that we can do some things here in a spreadsheet or in a graphing calculator like Desmos. So all right, let's just say I have that mu is equal to 24. Okay, now I have mu equals 24 there. If I leave it that way, I can't use the 24. I'll have to keep typing 24 all the time. And it's kind of a silly thing in a spreadsheet to not make numbers accessible. So I can say mu equals 24 like that, just to remind me. Or I can come over here and put the 24 there, so that now I have that number and I can get to it. And then the same thing for sigma. And let's just make that, something like 3. Okay. Now from that, what I'd like to do is calculate a probability. So, for instance, what's the probability that x is less than 29. I'll put an equals here, and I could look that up in the Z table by doing 29 minus 24 divided by 3 and so forth. So let's also do that. Let's get Z here. So Z equals, and if we were going to do that, we would have to take our observation, our 29. Now I've got that in there, so I have to retype it. 29 minus the 24. Now I could type 24, but it's right there. Click on it. There, 24 divided by 3. It's right there. And there's my number of standard deviations. And so we can also do this similar to looking it up in the table and see that we get the same answers. So this is our 1.67 thing that we have there. Okay, so let's calculate those probabilities. Well, you can use norm. Now the first thing that comes up here is norm.dist. That's the newer one. But if you just say norm.dist, the only difference, we'll see that in a moment here. So they'll both ask for the number. Well, that's our 29. Then for the mean, that's our 24, but I've got that number there, so I'll click on it. And then our standard deviation, the 3. Then it asks for whether we want cumulative or density. Well, we want cumulative. You use a 1. Now, the only difference between norm.dist without a dot and norm.dist is I actually could have put my closing parenthesis after the B2 and not put the comma 1. In norm.dist, I have to have that 1 there. But I do that and I get 0.9522. Great. Okay. Now, let's check this one. This is a standard normal. So this is the way I would look it up in here is I still use the norm dist. My number now is the 1.666667. My mean is 0 because it's a standard normal. My standard deviation is 1 because it's a standard normal. Oh, and I can put the, well, here I'll show that I don't need that extra 1 when it's not norm.dist. I hit enter, and there I get 952209. Same number, but it's kind of nice. And I don't have to do the extra step of creating the Z value, the number of standard deviations. I can just use the raw numbers, the 29, the 24, and the 3, and just plug them right in. Okay, now, but just like the table, this always just does that left-hand proportion or that left-hand area. So if I wanted, say, the probability that x is greater than 29, I would need to take 1 minus this number. So equals 1 minus that probability, and I get that. So under it, I'll do, I'll say that this is 1 minus the probability that x is less than 29. Whoops. Okay, so that's the only way we're going to find it in here, is to do the 1 minus thing just like in the table. So it doesn't really save us that step. And similarly, if I want something a little more complicated like the probability, I'll start with that. Let's take, say, from 25 to 29. Okay, so there's the probability from 25 to 29. I want that. Well, again, just like the table in the back of our book, the only way I can get this is to take the probability that x is, I'll double click there, okay, is less than 29 minus the probability that x is less than 25. Okay, so that's what I have to do. Well, so I've calculated that probability, the probability x is less than 29, but I need the probability that x is greater than 25. Okay, so I could write it this way, that x is, well, actually, no, I can't write it that way. Okay, x is less than 25. There we go. So I'm doing that subtraction, and okay, so here I need that norm, and just to show I could use a dot dist, and my number 25 this time, the mean 24, the standard deviation 23, and I do absolutely have to put that 1 there. This time I hit enter and I get my 0.630558866. Okay, I've got that. And so to get this probability, I need to take this probability minus that probability. And so I get those, and it's the 0.321. And so there is using a spreadsheet. Okay, and all spreadsheets will pretty much have these same formulas. I think they'll all have both the norm dist and the norm dot dist formula. Okay, but there we can get it, and again, it works just like in the book. Now, there's a great calculator called Desmos. It's on the web, DESMOS. I type it in there, I hit enter, and I just go here and I pick graphing calculator. If I do this one, I have to do one more click to get to the calculator. But here's the calculator. And what's nice is it graphs things, which in this case, actually, it is nice. Now, I have to tell it I want a normal distribution, but I had to tell the spreadsheet the same thing. And so now I don't actually have to name it anything. I could do something like n equals and then name it, but I don't even really have to do that, only if I want to use it later. But for now, we just say normal. Now notice how everything's italicized and it's putting all this stuff up. Yeah, because it doesn't know I want the normal distribution yet. And then I write DIST, normal, oops, I think I need a lowercase here. Yep. Once I do the lowercase, so it does need to be lowercase, but it changes everything to a normal font, not a italicized font. And then, now I have to put the opening parenthesis. Now if I take it away, notice it's got a warning thing and so forth. I put that there. It automatically says, oh, okay, you want a mean of 0 and a standard deviation of 1, right? So that's fine. I could do that, and I don't have to put anything else in. I could put the 0 and 1. But I do need to, if I want something different than the standard normal, I need to tell it that. And we had a mean of 24. And notice, now it says mean. It doesn't say mean equals 0 anymore. But it still says standard deviation equals 1. But as soon as I put the comma, it's expecting me to give it a standard deviation. And we'll go with 3. Now, it's happy, but I'm not. So there, I put my closing parenthesis. Now, notice what it did. It's plotting it. Now, but to see it, I have to come over here farther because the mean is 24, and you can just barely see it. Well, I can go up here, and you don't have to do this if you're working with this, but I think it's a nice idea, at least to see that this will make some nice pictures. So I'll go to projector mode. Again, you don't have to do something like that, but it shows makes everything show up better on the screen and so forth. Now, so this is the y values are really small, so I'm going to go from 0.1 to like or minus 0.1 to 0. Well, and then I can see up here it was too short, so let's try 3. And then I'll click out here. And there it is. And that looks just like the back of the book, right? There's the normal distribution. Now, like I say, I didn't have to do that, but for our demonstration, I kind of want you to see this. So now, if I click Find Cumulative Probability, that was what we did with the ones back on the spreadsheet. It starts from minus infinity to infinity. And it has everything shaded in here, and it says, well, the proportion is 1, or all of it, or 100%, or the area is 1. Okay, it's all 1. But we wanted to know for the probability when x is less than or equal to 29. And so I'll just go up here to the max and say, well, it's less than or equal to 29. Put 29. And notice it drew a nice picture there. There's 29. And it's shading everything to the left, just like in the back of the book. And it says 0.9522. And if I go back to the spreadsheet, 9522, same number. Gave us the same answer. Isn't that lovely? And now, but what's nice is if I want either of these other two items, so say the probability between 25 and 29, in this case I don't really have to do any extra stuff. I just say, oh, well, the minimum then is 25. And it shades the picture so I can see that I'm doing what I wanted to do. 25 to 29, I get 0.32165. That sounds familiar. Yep, 32165, and it just did it for me. And like I say, if I take the time, I've got a nice picture to look at. And then if I want the right-hand probability, well, that was x was greater than or equal to 29. Well, that means 29 is the minimum. Well, now it's 29 and 29 says there's nothing in there. Well, sure, that's true. But get rid of the 29. Now, it doesn't have anything there, but look at the shading, look at the number. It is assuming infinity without me putting it there. And if we go back here, 0.4779, 0.4779, same answer. So this Desmos graphing calculator, really nice for a normal distribution like this to calculate these probabilities, and if I want to see the answer. And if I, like I say, if I see it when I got out of there, it made it an infinity. If I get rid of that one, and I could click down here, and now it's back to minus infinity and minus infinity. Okay, but that's nice because 25, so 25 and up, 0.369. If I want to do the 25 to 29, there we go. Okay, so there we have it. We have the Desmos calculator, very easy to get to, very simple to use. There's a lot of help for Desmos. If you type in things like Desmos and statistics and so forth, you can find things on that it has. But we'll look at some of those as well as with the spreadsheet. The spreadsheet's where you're going to get your data usually, and so I think it's a good idea to know how to use those. But also, when you've got something as nice as this, I hate to not show it to you. And so the Desmos calculator, very, very nice option as well. Okay, so hopefully this video took. Sound worked and everything.